My name's Rusty Belcher. I'm going to be going through the Factory Design Suite, Autodesk ReCap, great combination class with you guys. I don't have a fancy clicker, so you guys are going to have to bear with me here. I'm an application engineer with Imagine Technologies. I work with customers all across the country. And really for the past 5 years, I've been really focused on Factory Design Suite. I got a chance to work with Autodesk about 5 years ago when that tool rolled out. And I've been a great fan of that tool. I got a chance to actually write the training material, the current, well, it's kind of old now, but the training material for Factory Design Suite. I got a chance to do a lot of marketing videos for them, and I got a chance to work with them throughout those first couple of years of Factory Suite. And I know there's some Autodesk representatives from Factory Suite here. I think Jared Bunch was here, and he's the, Jared, what's your position? User Experience team, so great. And Jared's got some free passes for a roundtable tomorrow. If you're a Factory Design Suite user and you'd like to go to the Factory Design Suite roundtable, see Jared after this class. So I got a chance to use Factory Suite for a while, and a few years ago, well, it was the second year of Factory Suite when they introduced point clouds in Inventor. I don't know if y'all remember, it's about 4 or 5 years ago. And we had this conversation during that time that we had to show Factory Suite putting assets in context of a point cloud. It was very, very crucial. And I remember about that time I asked this question. I said, well, instead of scanning the facility, why don't we scan the machines so that I can take the machines and use them as the assets, just a point cloud asset. And that idea has for the past 4 years, has had a little bit of traction. My background, I'm a CAD guy, I guess, like most of you. I started about 25 years ago in AutoCAD. I worked at Newport News Shipbuilding for about 16 years. And I remember one day, I was a young AutoCAD guy, brand new to AutoCAD really, and we had a cruise ship come in, and this guy walks off the cruise ship with a 4-foot tall letter E. You see the cruise ships and the names on the side of the ship? Well, it's a piece of steel that they paint and they weld up there on the ship. And he comes into our office, and we worked in the mold loft, and we made ship parts for ship repair. And he said, I need a 3-foot letter E. And I also need a letter Z in the same font as this letter E. And he dropped the E off and he left. That's all he said. And we didn't know what we were going to do. And I remember thinking, this was so long ago, digital photography had just come out. Anybody remember digital photography when you used to put the 3.5 floppy disk in the camera and take a picture? Oh, that's what we did. We hung that letter E on the wall with a couple of rulers. We took a digital photograph of that, brought it into AutoCAD, scaled it down to the correct size or up, and then we traced it. And then we made the letter Z from the letter E, and we were able to cut the steel for that project. But that's the first time in my career when I actually worked with reality capture. I actually took a real-world object, put it into my CAD software, and then I designed with that. And that's really the focus of what we're going to talk about today. If you guys have been to AU before, you guys are used to an AU class. I've got the class summary up on the screen. But really, in the past 5 years, we've seen reality capture just become commonplace in design. It is incredible how almost effortless it is now to generate reality captures. How many of you have got a reality capture app on your phone? Anybody got one? All right. If not, you got some homework. Go get 123D Catch and play around with that tool. It is so commonplace, your phone can now do reality capture. They're starting to come out with computers that have a little scan plate in front of the computer. You set down the piece of a graphic or a magazine article, and next thing you know, that's up on the screen. It captures it immediately. So reality capture being commonplace, and of course, I love the Factory Design Suite. I want to use both. I want to work in the Factory Design Suite in context of reality. So that's really the focus of our class here. I've got 4 bullet points. We're going to divide the class up into 4 segments. The first one is cleaning up your scan. The laser scans coming from various scanners, various sources. ReCap is a fantastic tool to help you get the scan clean and get the exact data out of that scan that you need. So we're focusing on some of the techniques for cleaning up a scan. Sometimes you want to generate 2D drawings from your scan. Anyone who's got, there was a number of people who had scanners in the room. Is anybody producing 2D drawings from your scan today? Is anybody doing see a few hands there? That's not necessarily a fun task. Most of the time it results in us tracing the scan with CAD geometry. So we'll talk about that and a tool called Vectorizing, a little workflow that we came up with. We'll also take a look at just the traditional approach of using a point cloud scan in a Factory Design Suite layout. We'll take a look at the traditional methods and all the tools that are in Factory Design Suite that support point cloud integration. And finally, we'll finish up on my favorite topic. We'll investigate the process of using a point cloud as the factory asset. To use a point cloud just like we would traditionally use a solid model of a piece of equipment. So I think with Autodesk ReCap, in my mind, its main focus is to clean and orient your scan before you start using it with your CAD solution. Now you can do a lot of things with ReCap. You can measure reality. You can take this entire space and put it on your desktop and start pulling measurements, and it's a fantastic tool for that. But I want to utilize the scan downstream in other CAD applications, and it has a lot of tools that support that workflow. So to start off, I think by design, our Autodesk applications now, the current releases of the Autodesk applications, they read ReCap point clouds. And in the case of Inventor, that is the only point cloud that Inventor will read is a point cloud that's generated through ReCap. The newer versions of Autodesk or of AutoCAD have gone the same route. The primary cloud file that you read into AutoCAD now is an RCP or an RCS. Now you guys some of you might have a third-party add-on to your AutoCAD or to your Inventor that allows it to register and read other point cloud scans. But I'm talking about out-of-the-box functionality. ReCap is kind of the gate we have to go through to take point cloud data into our CAD applications. How many of you have used ReCap? Help me out, raise your hands. How many of you have, okay, good. So most of you have utilized the product. You know what the file the file conventions are. An RCS is a ReCap scan, and an RCP is a ReCap project file. So when it comes to AutoCAD, AutoCAD right now in the current release reads natively an RCP and an RCS. That's just about it. With Inventor, absolutely. The only two point clouds we can read is an RCP and an RCS inside of Inventor. Now, the Factory Design Suite also comes with Navisworks. Navisworks, if you're using laser scan point clouds, you absolutely have to have Navisworks. It is a fantastic tool to allow you to visualize your point cloud scans and possibly combine scans together. But Navisworks reads everything. Of course, it reads the ReCap data, it reads the scans, it reads the project files. It also reads ASCII, it reads text clouds, it reads Faro, Leica, Regal, Rigel. It reads all of the typical scans that are generated and you can use. So the Factory Design Suite does absolutely support the use of the clouds, but in many cases, you've got to utilize the cloud via ReCap. The cloud has to go through ReCap first. So I want to talk about why I want to clean the cloud up, all right? ReCap's awesome. I can look at millions of points on the screen in Autodesk ReCap and everything works fine. But as soon as I take those points and put them in a CAD application, typically the CAD application is going to slow down. It's not going to be, the performance is going to take a hit when I drop 10 million points inside of Inventor. So anything I can do to reduce points is a plus once I get into the Inventor environment. Fewer points, better performance. Also, anytime you're bringing a point cloud into your CAD environment, you want to take advantage of orienting your point cloud scan with ReCap. There's no way, when they took the scanner and they went through the facility, there's no way that that building is going to line up on your X and Y UCS system in your CAD application. It's going to be all kinds of different angles. Typically it's upright, typically the Z-axis is upright, that's fine, but it's not going to line up with the X and Y axis. A ReCap can fix that before you bring it into your CAD system. So it's a fantastic tool for that. In this segment, I'm going to talk about a few of the simple tools inside of ReCap that allow you to clean your scan up. So we're going to take a look at the orientation technique, setting up your UCS with the point cloud. We'll take a look at that. We'll also take a look at the limit box and hiding points. Anytime I can hide points, makes it easier to expose the points behind those points. We'll take a look at eliminating points with the selection tools. I want to go through the 3 selection tools with you. I want to get rid of the floor in this particular scan. I want to use orthographic mode. This is a fantastic benefit that ReCap brings to the table. It takes a real space where it's scanned with perspective, and we can convert that to orthographic view. Aren't your drawings generated in orthographic view? Doesn't this start to look like the line work you'd want to see for your building? Well, we can display our cloud in orthographic view. It makes it easier to clean up. And there's also some downstream benefits if you ever want to try to generate drawings from what look to be lines. We'll talk about the window selection and the fence selection. Those are fairly straightforward options. And we'll talk about exporting the scan. How do I get the scan from ReCap into a CAD application? And there's a lot of options there. So we'll take a look at those options there. And then finally we'll end up with the scan inside of Inventor to where we can start placing our assets in context of that particular scan. And this in my mind is the traditional use of Factory Design Suite and point clouds. So if you guys bear with me, I'm going to launch my ReCap application. Make it a little bit bigger for you guys to see. There we go. And I want to launch, this is the bottom left corner of a building, of a machine shop. Now, we're going to have different scenarios as I work through with Factory Design Suite. And our first scenario is kind of simple and fairly straightforward. I have got a machine shop with CNC equipment that's already in place. Now, we just bought, in this case, we just bought some new CNC equipment. And we want to replace our old equipment with the new equipment. So, I need to take this scan of the building, of this corner of the building, and I need to get this into Inventor so that I can place my new assets in context of this scan. So the first thing I want to do is hide some points. To do that, I'm going to use the limit box. All right, the limit box down here basically puts a bounding box around your point clouds, and you can just drag the box and hide the cloud. We are hiding the cloud at this point. We are not erasing anything at this point. I love the option to highlight the edges. So when I'm bringing the roof down, I can see the structure of the roof. It kind of highlights that. If I come down further, I can see these rectangles. Those are some ductwork. And once I get below the ductwork, I know I'm right above the equipment. I know I've basically eliminated that overhead space there. So I'm going to confirm that. And real quickly, we have eliminated quite a bit of points. We've hid them temporarily. Later on, we'll go back and unhide them, and I'll show you that. Now, the next thing I want to focus on is orienting the point cloud to my UCS, or to a legitimate UCS direction. All right, now I've already done this once. If I go to the display panel here, the display flyout, I can come here and find Update Origin. Now, I've already set up my origin to be the corner of the garage door here. But the steps for this are actually pretty easy. All you have to do is come in and select a point. I'm going to pick a point here at this corner of the door. Now, being a CAD instructor, you got to forgive me, but how many of you have taken a CAD class and the CAD instructor says, read the tooltip? All right, that's all you have to do. Once you pick the point, it says, click to update, press enter to confirm, or tab to update the orientation. So if you hit the tab button, you can actually see the X, Y, Z orientation. And by default, you set the Z axis first. Now, I will tell you most of the time, if you have a laser scanner, it does a really good job of defining up. All right, so the Z axis is usually defined very nicely. Typically, I don't have to worry about which way up is. So I'm going to hit enter to confirm that. And now I'm going to select the X direction. And to select a direction, you click a cluster of points, either on the wall back here or maybe on the wall back here. And the X direction will be normal to the cluster of points that you selected. So once you set Z and X, Y is then default, and you're ready to move on. Now, like I said before, I've already done mine. Mine's set up here at this corner. And I want you to remember that I set the UCS up at this corner right here. All right. So I need to start cleaning some of the points up. I love the fact that I've got my view cube. I can look at this in any angle I want. And the first set of points I want to eliminate is the floor. With Factory Design Suite, when you get to Factory Design Suite provides its own floor. And having these points on top of that floor, it's just redundant. So I really do not need what is probably over 1 million points just to define a floor that I already have in my CAD application. So ReCap gives us a number of selection tools. I can come in and use the plane selector. And all you have to do for the plane selector is pick points on the plane that you want to select. You can pick multiple points. I'm trying my best not to pick a point right underneath of one of those scan positions. Trying to stay away into points that I know basically multiple points have confirmed that's the floor. Or multiple scans have confirmed that these points are the floor. I hit the enter button and all of the points in that particular plane are highlighted. I can change the depth of that. Right now it's about a 50 millimeter deep selection through there. You can change that if you want. And then I'm going to hit the delete key. Now that's a deletion. So these points have been deleted from the project file that I'm working on. The scan is still out there in the background as a supporting document. If you want to reload that, the points are in the scan, but they're not in the project file right now. The smaller the scan, the better productivity or the better performance I'm going to have inside of Inventor. So any points I can eliminate, that's a good thing before I bring it over to Inventor. So perspective view is on by default with ReCap. All right, you need to understand that. If I go back to the display flyout, you can turn off perspective view. This puts you in orthographic view. And I'll ask you a question. Don't the walls start to resemble lines now in orthographic view? That's typically what I want to see in my final CAD product or my final CAD drawing. I want to see lines. So by being able to put a real space in orthographic view is just incredible. Now there's a number of selection tools. You have a window selection and you have a fence selection. With the window selection, you can come in and you can carefully drag a rectangular window, and the points, once you let go, you can simply delete the points in that particular area. So I've got some equipment over here. I want to get rid of that. And I'm just going to use the simple window selection to do that. I'm going to preserve my walls. I'm going to preserve, in this case, the architectural design. There we go. Now there's a column for the building. There's a building column right there. So I'm going to drag a big rectangle there, and we'll eliminate all of that. There we go. You also have a fence selection. So I've got the fence selection lets you draw a fence. There's a sink on this back wall over here. I want to save the sink. We'll come out here. We'll get rid of everything else. There's another column, so we'll go up around the column. will come up on this side of the column. There we go. I'm just hitting enter once I have that selected, and then the delete button. And again, deleting the points removes them from the project file. So real quickly, I've got the basis of the scan that I want to send over to Inventor. Now, remember the limit box. The limit box just hid the points. We can go back to the limit box and we can reset it and bring those points that we hid in the beginning back. So now I've got basically an empty room. We've gone in and cleaned out all the existing machinery that was there, and we're ready to send this back over to Inventor. It's much smaller. I've checked this out. I eliminated 2/3 of the points in this file by going in and cleaning it up prior to using it inside of Inventor. Now, when you send it back over to Inventor, or when you send it there, you need to export it. Well, I'll take it back. You don't have to export. You do have an option here. You can either choose to export it as a single scan, a brand new RCS file, or you can just basically open the project and link the project into Inventor. Remember that the project file references the scan files. So if you have a data management system, you have multiple files to keep track of. If you just want to send it over as an RCS, basically it means you have one file to track, that's your scan file. So I typically would export this as an RCS, and I would call it whatever the facility name is, clean, so that I know that I've cleaned it out. Now, I've gone ahead and I've already exported this. So let me jump into Inventor, and let's bring that into Inventor. When I start the Factory Design Suite, it starts a new layout. There's the floor that I get normally. Notice the X and Y axis before I bring in the scan. The Factory Design Suite 2015 has the point cloud panel right up at the front, so I don't have to go in the back and find it. I'm going to attach my cloud, and I'm going to come in. I'm looking for an RCS in this case, and there's my bottom left clean. It's an RCS file. Now it's going to come in on your cursor. You can't snap this. You might as well just click to drop it off, and then the dialog will help you position it. So here I have insert at origin. You'll notice that the origin lands exactly where it was in ReCap. So I've now put the cloud exactly where I needed it to be. You can also modify the direction. In this case, I want to look at it backwards, so I just spun it 180 degrees to use inside of Inventor. You can inside of Inventor, you can dial down the density of the points so that it shows fewer points. And in this case, we're still about 6 million points, still what we've got on the screen. But it works pretty good. So I click OK, and I've got my building inside of Inventor. And in case you haven't used the Factory Design Suite, it comes with a large library of assets. So I can type in CNC Haas. They'll probably have a couple of their Haas machines on the show floor today. And I can just drag this digital model of a CNC machine in, and I can drop it in context of the cloud. So I can start positioning my 3D models in context of reality. If you think about it, it's now the merging of a digital design and reality. I can start, you'll see a little bit later, I can measure off the walls. By the way, the scan comes in full scale by default. If your scan was done with a typical laser scanner, Faro, Leica, it's going to come in full scale from ReCap automatically. So I didn't have to scale that scan up at all. But that's the traditional use of point clouds in Factory Design Suite. Do you guys see how much I rely on ReCap now? I have to have that tool to clean and orient those scans before I bring them into my CAD application. By the way, this workflow works exactly the same for AutoCAD. If you're an AutoCAD user and you want to bring in the cloud to AutoCAD, the same workflow would work. It's absolutely up to you as to how you want to do it. Now, I mentioned before that many of us at some point in our design cycle, we need to generate 2D vector data from the cloud. Many of us are currently, we'll take the cloud into a tool like AutoCAD or Inventor, we'll go to orthographic view and we'll trace the cloud, and I do that quite a bit, I will absolutely admit that. AutoCAD or Autodesk has introduced a few tools here this past couple of releases to automatically generate vector data from point clouds. I'll talk a little bit about those coming up. But I'll be honest, I went into a job site a couple of months ago and they were generating line work from point clouds. I wanted to see how they were doing it. They were taking the point cloud in AutoCAD, getting it in orthographic view, and getting enough of the lines to look like, enough of the points to look like lines that they would just simply print the viewport as it was. So they were just simply printing the points in a viewport and calling it vector data, and it really was not vector data. It generated a pretty good line work, but during that conversation I mentioned, you know, if you're going to do this, why don't we just take a screenshot from ReCap and use raster design to trace the lines. Raster design does a great job for that. And something clicked in my head. I don't know, this is one of my favorite apps on my iPad. It's called Autodesk Vectorize It. Autodesk Vectorize It is an Autodesk product, and right now it's only available on the iPad. What it does, it allows you to take any picture and it will trace the raster data and vectorize it for you automatically. So I started to think, wait a minute, if I can take a screenshot of my orthographic view in ReCap, I could send it to this and have it generate the vector data for me automatically. And that's exactly what I did. It's not perfect, and again, remember, we're dealing with reality here. So in this example, those machines, they're not lined up perfectly together. They're on that space and they've been knocked around a little bit, so they're not parallel with each other. But it does a very good job of converting raster data to vector data in a very automated method. With the Factory Design Suite, typically I use my 2D lines. There's a tool called the DWG overlay. It allows me to take a 2D cross-section, lay it on the floor, and then I can snap my assets to that AutoCAD vector data. So it stands to reason I would want a cross-sectional representation of my point cloud landing on the floor so that I can snap my assets to that. Now, if you're going to go this route, you have got to understand your initial scan has got to be what I call ultra clean. You need to get rid of every point in the file that does not represent the lines that you're looking for. So here's another scenario. Let's say that I need a cross-section of that particular room that we were working on. I need to know where the existing machines were. Maybe there's a power supply that was built into the foundation for each machine, and I need to put the new machines in the footprint of the old machines. But I need this as CAD data, as traditional 2D vector data. So how am I going to get that out? So I'm going to use the Vectorize It approach here, and at the end of this I will talk about the other approaches that are available. But if you have to start off by removing all points that are not the lines that you're looking for. So this cleanup can take a little bit longer than the previous cleanup I did. So let me jump into ReCap and let me open, I call it my ultra clean file. So here is the ReCap project file. I have deleted a lot of points. I have noticed that the more points I delete, the project file slows down a little bit over time. So that's just something I've seen with ReCap. Yep, absolutely. To make sure that I got good solid lines, I had to make the cross-section deeper so that the lines appeared more solid in the top view. So that's a good question. Awesome. Got rid of the floor, got rid of the roof. In that case, those were easy with the limit box. And then I could go in and just erase the points with the selection tools I used earlier. So I'll ask the question, it looks like lines now, doesn't it? Those are the lines that I want in AutoCAD, if you want to focus on that. So there's a couple of things I want to do before I generate my screenshot. The grid, you can turn the grid off. If you go to the little eyeball over here, come down to Tools, you can toggle off the display of that ground plane. So if we didn't do that, the ground plane would be in the screenshot and it would ruin everything. A couple of other things, the point density, or the point display. A lot of people like to come in and they want to make the points like 1 pixel on your computer. And that makes the lines really ultra thin. That might be what you want to do, but in some cases, it'll mean I have gaps in the line. And a simple way for me to remove the gaps is to take the point display and bump it up to 2. Make the lines a little bit thicker. Works out pretty well. Again, I've removed everything in here that wasn't one of these lines that I wanted. The last thing I do before I generate my screenshot, I select all that geometry. When you select the geometry, the highlight color takes over and now everything is either white or whatever that color in the background is. And then however you take your screenshot, I've got Snagit up here. However you take your screenshot, you set up your screenshot, you save your file, and typically you have to send it to your iPad via Dropbox, email, or whatever, but you got to send it over to your iPad. Now, this is the part of the presentation that makes me a little nervous because I'm going to try to pull my iPad out and utilize it here. So you guys bear with me here. All right, I had this working earlier. I'm not going to spend a lot of time on this. I'll give it just a second more. All right, it's not syncing like I thought it would. However, it's a fairly simple application. All you have to do is take a picture of anything and Autodesk will trace the lines automatically. So if you take that picture, the tool does allow you to import your own picture. You can go through and trace it very, very easily with the application. It produces at the end, it produces a DXF file that you can use and send yourself a DXF from the application. So leave that off to the side. I'm sorry I couldn't show you that. But let's get back into, let's look at AutoCAD for a minute. Let me pull up my layer manager here. I'm going to turn off, I've cleaned this up a little bit. I want you to see what came out of that Vectorize It application. Autodesk Vectorize It generated all the lines that you see here. It's a little, I've turned on the line weight so that you can see these a little better. They're not straight. It's actually many, many lines. I've cleaned up some of these, but there are many different line segments that represent each machine in that particular cross section. Now, just to make my life a little bit easier, I did go in and add some rectangles that represent what I thought were those CNC machines. I just took a rectangle and went corner to corner and created a more reliable footprint. I did the same thing with the walls and the windows and the columns down here. So in the end, I kind of traced it myself, but I had a good foundational elements to trace upon. So once you have this AutoCAD drawing, what can you do with it? Well, back inside of Inventor, we have the DWG overlay command. The DWG overlay command allows me to take any AutoCAD drawing, I'm going to grab that Vectorize It footprint, and it applies it to the floor. So now I've got my AutoCAD lines on the floor and it matches perfectly with the point cloud scan. I will tell you, and there's a little scaling factor. Vectorize It allows you to scale the picture. You can apply a dimension to the picture. When you had the picture or when you had the data in ReCap, you need to take a dimension off of from one point to another. You need one valid dimension so that you can scale this back up through the Vectorize It process. But hey, that's what ReCap's for, right? Pulling real world dimensions from point clouds works very nicely. The Vectorize It app also takes that dimension into context so that you can send yourself a scaled DXF file back over. But now you start to see that these these assets, I now have a footprint on the floor of the original asset. So if I bring this over, you'll notice that in Factory Design Suite, I can actually snap my three-dimensional models to that 2D footprint. Now, I can almost tell right away, I'm going to have some trouble here. I've got the column which is way too close to this new machine that has to go inside of that footprint. So I might have to scoot it off to the side, but now I can do that in context of where the original footprint was versus where the new machine's going to go. So if you have the need to generate two-dimensional line work from a point cloud, this Vectorizing app works pretty well. I wish it would have shown better. I'm a little disappointed in my computer not seeing that, but it does work quite well. I do have some screenshots of it up on the screen. When you come in and the Vectorize it tries to sense the lines. It's basically raster data. It tries its best to draw the line work through there. There is an option to surround the pixels or to draw a line through the pixels. So in this case, I just drew the line through the middle of the pixels. You can also simplify your geometry and remove smoothing. Those are two options in the application. The application allows you to define a dimension in the sketch or in the screenshot. In this case, I had a 19.3 meter measurement in ReCap. I plugged in 19.3 inside of Vectorize it so that the data came back into AutoCAD the correct scale. Or at least it comes in so that it's scalable. You know what it is, you know what it needs to be, and you can scale it up to the appropriate size. I also showed you that there will be some traditional cleanup. When you're dealing with reality, there's no way these walls are flat, right? They're all curved, they're all leaning just a little bit. And that stuff shows up in the scan. It will show up in your line work as well. So you just do the best you can to draw conventional 2D geometry on top of the vector data. And if you have to, scale it up to suit. I showed you that I was able to bring that into Factory Design Suite, lay that on the floor, and then I could place my assets in context of not just reality, but now the conventional 2D footprint. It's part of the DWG overlay. Now, there are other methods for converting point clouds to geometry. Many of you have third-party applications that do that for you. There are third-party applications that look for cylinders and can actually model a cylinder in 3D. Or you can, AutoCAD, in the new versions of AutoCAD, there's a big if here. If your scan has been registered in a way that defines planes and cylinders, you can extract the center lines of cylinders and you can extract the edges of a point cloud. But your scan has to have been registered in a certain method. I have plenty of old scans that doesn't work inside of AutoCAD. That doesn't work for me. If you use the AutoCAD methods, AutoCAD is analyzing the points and it's trying to make a line fit the points or a plane of points. That's different than what I did. I converted a raster screenshot into a viable footprint. AutoCAD's actually trying to analyze the points and make a line fit through a particular plane of points. So it is different. It's a different methodology, but it is part of the Factory Design Suite, and I would encourage you to check that out. In either case, you've got to account for accuracy in your design. You guys understand that every time I go to draw a dimension or check a dimension, there's a human error involved. I might have picked the wrong points for that dimension. Anytime I'm trying to scale stuff up or down inside of AutoCAD or Inventor, there is a possibility for an error because I'm just a human being. So you've got to account for that. You need to check and recheck your accuracy against your original scans. All right. So let's talk about creating a factory layout in context of a point cloud. And to me, in this part of the class, this is where I'm going to focus on the traditional use of clouds in Factory Suite. Creating a factory layout in context of the point cloud, there are many, many tools. that the Factory Design Suite has to utilize point clouds in the factory layout process. So we're going to take a look at those. But really, we're talking about merging the digital design with reality and all the tools you need to account for that. For instance, I need a measurement tool that I can measure from a digital model to a point cloud. I need to be able to put points on that cloud and measure it. I need to be able to put planes on that cloud so that I can define a work plane. All of these tools are available inside of the Factory Design Suite. But if you ask me, those are the little tools. I want to talk about the main tool first, and that's clash detection. Interference analysis between point clouds and 3D models. This is one of the main selling points for Navisworks, the Navisworks Manage application. If you're looking at Factory Design Suite, there's a premium, middle-of-the-road version and an ultimate version. This feature that I'm about to show you is really the only thing in the ultimate version, in my mind, that's what you buy. This is what you're getting, is the ability to analyze point clouds in digital designs for interference. So I'm going to jump into Navisworks. It's a member of the Factory Design Suite. And here is our scenario. I've got my new equipment laid on top of the footprints of the old one, and all of it done in context of the point cloud. All right? So this is my best shot, and I want to check interferences. Now, interference analysis is critical to any design methodology. All right? You guys all know the digital mock-up or the digital prototyping scenario. This is why we build it on a computer, so that I can check for interferences. But let me ask you, what is a cloud? What is it? It's just a bunch of points in space. All right? There's no face there. There's no edges. There's no geometry. It's just points in space. It's a fog that looks like the architectural design. Well, Navisworks allows me to do clearance analysis between points and solid data. There's a tool called the Clash Detective. You can bring this in. We're going to add a test. And then you can do tests in a variety of ways. As an example, on my solid side here, here's the solid side, I'm going to select all of my Haas CNC machines. All right? Just like Inventor, you have a browser, a selection tree. You can select all the elements that are in the scene. On the other side, I want to balance that or check that against the point cloud. On the solid side, I'm looking for surfaces, lines, and points. I'm doing a tolerance or a clearance analysis for 2 inches. If a point cloud comes within 2 inches of a solid model, show it to me. On the other side, I've set this up to show points. Just look for points. So I can run the test. And then I'm immediately prompted where the problems are. So I could tell you right away that the control panel of this CNC machine is closer than 2 inches to the column, to the current setup. Maybe this is a power supply panel on the column. But I know that. Now that I know that, I could write this up. I could go back to my digital design, back over in Inventor, scoot things around, and clear that tolerance. But can you imagine if you found this during construction? How much of a problem that would be? All right? Just in moving the supply lines and the equipment, maybe the bolting connections that are in the floor that mounts this particular piece of machinery, just that particular change could buy your software and your subscription for a couple of years. But you have a chance to save that amount of money right now. So that is the main tool for utilizing points and solids inside of Factory Suite. But there are several others. I'm going to close this example. And let me open up that Vectorize It assembly. So here is that same assembly, and just this time I'm in Inventor. I wanted to show you some of the other tools that are available. So I mentioned you need a good measurement system. You need to be able to measure point clouds to solid data. And inside of Inventor, it's really not a separate tool. You just go to the distance command. The distance command automatically senses the planes of a point cloud. So I can measure from this wall to this point, and I could accurately tell you that that's 120 inches of space between the wall and the part. All right? It works very, very well. It's a great feature. Along the same lines, we have the cloud point. If you ever need to measure specifically between 2 points, you can go up to the point cloud panel and you can start the cloud point command. This allows you to put a work point in space on top of a cloud point. So if I did that twice, I'm just picking arbitrarily here, and I'm sorry, just for time's sake. But then I can measure over in the browser from one point to the next, and I can tell you the rough size of that garage door opening is about 150 inches. Later on in the class, those work points become critical to hang information on my potential point cloud assets. So those points are nice. We also have a cloud plane. If you need a work plane in space on a cloud, you can start a plane command and basically just create a plane in context of those points. And if I was looking for the corner of the room, if I put another plane here, now I have 2 planes in space. Where those 2 planes intersect would be the corner of the room. I could put an axis there. The box crop tool. Inside of Inventor, you can still crop your point clouds. So if you've brought in a number of points and you want to hide them temporarily in Inventor, you can do that. So here's the cloud. This cloud has already been cropped. There's a little symbol up here that shows you that this cloud's been cropped already. So I'm going to right-click on this and uncrop it. So there's the ceiling, all that ceiling structure there. And I want to show you how to crop it. So I'm going to look at my left side view. I'm going to go to the box crop command, and you simply draw a rectangle. You draw a rectangle around the data that you would like to hide. There is an option to keep the points inside or outside. I'm going to choose the outside, and then you can also readjust the size of the box if you need to. You can agree to that, and you can hide those points. And again, those points are hidden or frozen, so by removing points, you improve the performance of the CAD application by doing that. So I've got the ceiling points there if I need them, but in this case I don't, I can hide them very easily. The other way to do this, I don't know if you wanted to go backtrack, if we wanted to import a ReCap project file, you could do scan regions inside of ReCap. So I could sequester different areas of the cloud in scan regions. And if we brought the ReCap project file in, I would have access to turn those on and off visually. So that is also supported. There are tools to display points in Navisworks. If I pulled up Navisworks again very quickly, there are tools whether or not you want to see the points or not. You can turn the points on and off with a single click inside of Navisworks. Navisworks can bog down. It doesn't bog down nearly as much as Inventor and AutoCAD will with point clouds. Navisworks can hold immense models, far beyond what Inventor and AutoCAD can hold. But if you ever wanted just a single click to toggle the points on and off, Navisworks provides that for you. And I've already mentioned the clash detective tools. It's a major feature of Navisworks. Now, I'll finish up this section again by pointing out the fact that AutoCAD does have tools to work on point clouds. The past couple of releases, they've introduced some point cloud commands that allow you to analyze the section lines, very similar to what I did in Vectorize It. It also looks for edges and corners and the center lines of cylinders. But again, I'll put a big if here. This only works if your scan's been registered in a certain method that it's looking for planes and cylinders. believe me, I'm not an expert when it comes to point cloud registration, all right? I work with guys all the time that they register my clouds, give them to me. I've seen plenty of clouds where some of these commands don't work because they weren't registered properly. All right, so we're right on track here. Now, this to me is the fun section. This is where I get a chance to do something I probably shouldn't do. I got to tell you, the other day I wrote about this section. I wrote about using a point cloud as an asset. And at the end of the blog that I wrote, I said I might never have to solid model again. I might be finished with solid modeling. If I can go and scan my equipment and generate assets from those scans, I don't have to do any solid modeling. So this means that I have assets that are enabled per reality. And in this next segment, we're going to do a factory design suite scenario. And I'm not going to do any solid modeling at all. I'm just going to use point clouds. I mentioned, I've asked a few of you earlier, what do you use your point clouds for? And traditionally, we use the point cloud to scan an environment. And traditionally, I'm looking for the walls, I'm looking for the ceiling, I'm looking for the floor, and power supplies and things like that. So in a lot of ways, we always use the scanner looking outwards for the architectural elements. Think of the scanner looking outwards in this room, all right? That's the traditional way we use it. Traditionally, we harvest the architectural walls, windows, doors, the ceiling, any of those architectural components that our equipment would foul, and that is important. All right, I spent more than half of this seminar with you on the traditional methodology. But I want to turn that around. Here's a scenario where I've got equipment right in the middle of my scan. I know that's kind of small, but I've got a forklift sitting there. Now traditionally, I would use ReCap to strip out the architectural line. There's a crane track that runs up here. There's the columns that support the crane. There's some garage doors in the back. Those are the things I would traditionally want to get out of the point cloud. But what if I aimed the scanner inwards and scanned a piece of equipment? I would know the exact size and shape of that piece of equipment without ever having to do any solid modeling. That Haas CNC machine you saw me use earlier, someone had to spend about an hour to model that particular piece of equipment. Probably they spent longer than an hour because they had to go measure the real world piece of equipment, take some notes, go back, make a 3D solid model that looks like that piece of equipment. But this forklift right here is not a model. That is the forklift. It's exactly what it was when you scanned it. I have been looking for an acronym for what I'm about to share with you. My wife and I were at dinner the other night, and I came up with this one. I want you to think of the word real, all right? Real. Reality-enabled asset layout, okay? Reality-enabled asset layout. I want to use the factory design suite with real-world objects, not 3D models. So now there's no way I'm going to get stuff wrong. If the scan is correct, then I know that machine's going to fit in that particular area. Has anybody ever wanted to take, you got a scan of one building and a scan of another building? Anybody ever wanted to take them and put them together and see if the equipment in one building would work inside of the other building? Well, the factory design suite's going to allow me to do that. So I remember back when somebody told me that modeling in 3D was faster than drawing it in 2D. Anybody here remember that? All right, and I remember saying, no way, no way. But then I learned 3D is a much faster way to work than the old 2D methods. What I'm telling you now is that generating assets with a point cloud scanner is faster than modeling them. Many of you are going to say, no way. I've been modeling for years, and I can model a piece of equipment in a couple of hours. All right? You can model a representation of a piece of equipment in a couple of hours. You can't model the actual piece of equipment. All right? Point clouds can be generated by scanners or cameras in a fraction of the time it takes for you to model it in person. Remember that when you model it, if I were to put a piece of equipment in the floor and the modelers in this room, all your experience combined, how long would it take you to model the equipment? If you don't have a tape measure, it's going to take quite a while because you've got to go up and measure that piece of equipment. You've got to record those measurements, get back on your computer and develop the piece of machinery. There's guys in the room that have a laser scanner. Set up one corner, 4 corners, and I'm done. I let the computer register, I put it into ReCap, clean it up, and I'd be finished in a couple of hours. And I would have the exact size and shape of that piece of equipment. No doubt. It would be real. In many cases, when I work with customers in Factory Design Suite, their machines already exist in reality. They've been using those machines out in that shop for years. And some poor guy, when they get Factory Design Suite, he needs to go out there and model those machines, and that takes forever. It really does. Point clouds are generally easier to create. Many of you who have been modeling so long, you kind of discount the fact that how long did it take you to get your skill and your experience? All right? So you have to be an experienced modeler to model equipment. You don't have to be you don't have to be a great guy to run a laser scanner. Listen, you set the scanner up, as long as it's calibrated right, most of the time you hit the button and you walk away because you don't want to get yourself in the scan. You go hide around the corner. Then you come back and move it around and you just make sure that you can see the object from all angles. It's actually pretty easy. How difficult did ReCap look to use? Anybody have? I'm amazed when I use ReCap. ReCap usually, I think I'm on my iPad because the interface is more like an iPad than it is anything else. It's extremely easy to use. So I can get rid of any unnecessary points very easily. Let's add another thing to the mix. Many of us don't have an expensive laser scanner. Okay? Many of us, the only thing I've got is my cell phone. Now, here's what should have happened. When I was on my iPad, I would have gone by a bunch of pictures of my truck. About a week ago, I went outside my house and I had an F-150 pickup truck, and I took about 60 pictures. I walked around my truck, took about 60 pictures, and I was able to create a scan of that truck with just my cell phone and ReCap Photo. ReCap Photo is a part of the ReCap family, and if you have subscription, if you have an Autodesk subscription, you have access to ReCap Photo. If you take the pictures of an object, it takes about 60 pictures to walk around an object, you can upload those pictures to ReCap Photo and it will generate either a mesh or a point cloud of that design that you can then download. You upload it to the cloud. It takes a little while depending on how complex the shape you're trying to find is. But it doesn't take long at all before you can have a point cloud of whatever real world object you need, and the only thing you've done is pulled out your camera phone.
What's the accuracy on that?
Not very, okay? That's true. That's absolutely, absolutely true. But tomorrow in our Factory Design Suite class, how accurate does it need to be? And we're going to do a class tomorrow about asset development, and we're going to talk about fit, form, and function. If the thing looks like my truck, if it's roughly the right size of the truck within an inch, I'm good to go. And you'll see here in a minute, I can let a lot of things go as long as that point cloud's roughly the right size of my truck. Yes, if you want high accuracy, your laser scanners are going to beat out your cell phone all the time. But my cell phone, well, I used to say my cell phone was cheaper than a laser scanner, but nowadays, these cell phones are pretty expensive. Any camera you can develop these by. There are ways to do rooms, although I always have typical, as long as the textures on these walls, if you look up on the screen, if you're using ReCap Photo, it hates reflections. It just has a hard time with reflections. It has a hard time with transparent objects, where a real laser scanner wouldn't. But if there's textures on the walls, it does a really good job. Typically, a couple of things, if you use ReCap Photo, you want to include the entire machine in every image. So in all those pictures, you see my entire truck. You want to take pictures from high and low angles. So as I was walking around the truck, I made one pass about every 10 degrees, and then I pulled out my ladder, went to the top of the ladder, and I did it again, looking down at the truck. So you want to take pictures from multiple angles of the piece of equipment. Usually you're talking about 60 pictures to generate a good scan. More pictures, the better. You can't take too many pictures. Avoid glare, avoid reflections if you can. I've seen some pretty elegant solutions to glare. It's Christmas time. Is anybody going to take that little frosting and squirt on your windows and make it look like it snowed? If your object is really reflective, go get that can and spray that reflection away. Just dull it, and you can get a better scan by removing that reflection. Avoid color contrast. I had a forklift once out in the parking lot. This is going to be the greatest scan in the world. It was an awesome forklift. I had all kinds of access to it, but it was surrounded by woods, and the woods were dark. And the dark parts of the forklift matched the background, and the scanner couldn't determine what was forklift and what was woods. So keep that in mind. You have to have a good contrast to your background. You need a consistent light source. So if somebody's thinking, I'm going to take my asset and put it on a turntable and spin it, and I'm going to stand still, no, that's not going to work. You need to walk around it so that the light's hitting it in a consistent angle. By the way, this carpet would be great to scan. If your floor is textured, your scan comes together a lot better. So if you ever, I don't know if you remember the 1-2-3D Catch stuff, but people would take their newspaper, the Sunday morning cartoons, and they'd put the object on that because the cartoon helped stitch the photograph together easier. So textures and surfaces are preferred. With ReCap, you have the option, a ReCap photo will give you the option to download a cloud, an RCS file. You can also download a mesh if you wanted to 3D print it, that is possible. You can also download an orthographic image. So this is crazy, but if I were to come in and scan the floor, and then I needed to detail this floor in CAD, I could generate an orthographic image, a TIFF file of this floor in orthographic view. So there's a lot of uses for ReCap photo. But in most cases, this is a generator I did. This is my generator downstairs. You guys have seen me do this already. I removed the floor, I cleaned up the cloud, I brought it into Inventor, and now here's a little secret sauce, all right, to make this all work correctly. By the way, I did scale it up. Let me time out. I do need one dimension on the cloud. So in reality, I measured either the distance from one bar to the next, or the diameter of the wheel, or something like that. So something that when I bring it into Inventor, I can scale it up to the correct scale. So that is a necessary situation if you're coming through ReCap Photo. Once it's the correct scale, here's what you want to do if you want to turn it into an asset. You go to the top view of this component, and you do a simple sketch of what this thing looks like down below. Just take the time. All this was a simple rectangle. I drew a circle for the filler cap. I drew a couple of capsules for the wheel. Keep it simple. This little sketch becomes very important for the factory design suite workflows that are downstream. If you're an Inventor user like me, I also took the time to add a surface patch here. These little voids, you can turn those into surfaces. Just a simple, flat little surface. And it makes all the difference for utilizing these things downstream. So altogether, for this generator, you're talking about an hour to take the pictures and upload them to ReCap Photo. It can take upwards of 5 hours before you get the email warning that your scan is ready. But that's cloud time. Once I have that done, I can download it, get it into Inventor, and generating this line work, force yourself not to go but like 30 minutes. I'm only going to trace this about 30 minutes of time, and I'm going to cut myself off. So you're only talking about an hour and a half, 2 hours of investment before you have this asset. And you know it's real. It's based in reality.
If you already have the 3D sketch, would you be able to bring that right onto the sketch plane?
Absolutely. If you already have this drawn in 2D, maybe an old AutoCAD block, You can absolutely sit this down. Although, I would want to make sure they line up good and as clean as we can. That's a great point. Once that's done, you can publish this as a factory asset. There's a couple of options. You can come in and add a descriptor, so you'll see a descriptors a little bit later if you want to identify it. But again, another important point, when you go to publish this, you tell it that you want the 2D representation to be the sketch that you drew. When you publish any asset, you can determine how it looks in 2D. So I'm telling it to use the sketch when I'm generating my drawing views. Very important step in the asset publishing process. Then you just use it as a normal factory asset. So let me jump into the scenario here. Let me jump back into Inventor. And I have a new scenario for you. So you've seen me use the machine shop a couple of times. Here's the scenario in this example. I'm going to take my machines from their current facility and I'm going to move into a new facility. And I want to use my same machines from facility A in facility B. This is typically a brownfield scenario with Factory Design Suite where we're moving from one facility to another. And I've got a laser scanner. So the first thing I'm going to do, I'm going to insert a model of the new facility. So I've always called this my Faro building, just because I know this was created with Faro. I'm going to drop this in. Now typically I would drop it in and place it, but for time's sake I'm just going to place it right in the middle of the scene. This is another benefit or another workflow that I would encourage you. Instead of bringing in your facility, instead of importing it into your environment, import it into a part file and then use the part file to bring it into the assembly. So have a point cloud, a part file that is just a point cloud. It's a nice workflow. Forgive me for just a minute. I do need to lower this cloud. So I'm just going to lower it, put it onto the Z. So if I look in the side view, that cloud is resting right on the floor at this particular point. Now, I did clean it up and I did trace it just like I mentioned before. Even though I didn't publish this, I still created the line work from the walls and generated that. Now, remember those CNC machines from our previous examples. I'm going to go to my asset builder and I'm going to do a search for point cloud. So here are all of my point cloud assets that I've generated for the class. I went in and I took those, there's that Haas CNC machine. That was from the original scan. This is from a separate scan, but I'm going to bring it into this scan. And I want to see if I got enough room to place two of these in position. So the factory asset lets me come in, I can track off of things, I can line things up. I want to see if I can get two of them between these columns. We'll put them in the same direction. If I wanted to look at the top view, I could absolutely do that. And I think I've got enough room. All right. I was also able to harvest a couple of lathes and some drill presses from that previous cloud. So here is a LeBlanc lathe. I'm going to bring this and put it in the background here. And we're going to put another lathe right there. These aren't really great scans. These just happened to be in the way when they were scanning the facility. And basically the scan got 2 or 3 scans, got that particular piece of equipment. If I had aimed the scanners at the piece of equipment, I would have had a much better scan than what I got here. I can do the same things with the drill press. There's my drill press. We'll bring that over. We'll add another one right there. These little descriptors, this is where I can just hover over that and it says, hey, that's the LeBlanc lathe, that's the drill press. That's the CNC V5 VFO machine. So there you go. So I can start laying out my facility, not with 3D models, but with point clouds. I can get a lot of extra use out of the scan that way. Here's a couple of examples just from various scanners. Here's the forklift. I mentioned that forklift before. That came from that real-world scanner. Here is a scan of a tractor. This particular scan was a high-end laser scan of a John Deere tractor. So this is one of the bigger scans that I have used in this process. So there is a very high-end laser scanner version of a John Deere tractor. It looks great. Here is a cherry picker. My neighbor was getting new windows in his house. I went outside, took my cell phone. This was actually done ages ago with that 123D Catch tool. That's where that point cloud came from. 123D Catch does not give you point clouds anymore, only ReCap Photo does. But it doesn't matter where you get the scans from, you can utilize them from any CAD source you want. Let's see, I was able to get a motorcycle off of 123D Catch. This scan turned out great. I don't know who took that, but I was able to download that one. And then finally my truck. Let me just bring the truck in. This is my Ford pickup truck sitting out in front of my house. My wife always says I have a hard time parking that truck, so there you go. I can park it a lot easier now once it's a digital mock-up. Now, why did I go through and do the sketches? A couple of reasons why. Here is an asset that Autodesk published, or somebody else published it. I think this was done with Autodesk. Here is a trolley for a luggage car. You see these at the airport? So whoever did this one, notice that this one doesn't have a footprint underneath of it. It's just a cloud. That's all that's there. So when I go to move it, I can't select it. There's nothing there to select. But because you put the sketch underneath your asset, you can scoot that thing around and place it wherever you want it. That sketch becomes the interactive element that you can reposition the cloud by. So I'm going to get rid of the tug. We're going to delete that one. Now, I hope you've never seen what you're about to see next. I hope this is what I've been building up to show you. Let me save this, and I'm going to save it as sample. And then I'm going to produce a new drawing. I'm doing this inside of Inventor. This would work inside of AutoCAD as well. I'm going to create a base view of my facility. And I can generate all of my line work from all of those assets at the same time. So I have the same ability to generate CAD data from my point clouds now. And they can be as detailed as you want. You'll notice that these are fairly simple. If you take the time and draw extra lines on your footprint, you can get that data and bring that in. So if you wanted these to look better or more accurate, you can add your own lines on top of that footprint. But these are assets. So for instance, I can go in and drop in a parts list. I can grab the balloons and I can start itemizing point clouds. You guys, I have never seen this before. There is no solid modeling in this process whatsoever. Yet I'm able to reproduce a good quality scan from the clouds. I could dimension if I wanted my documentation, if I need to dimension off to the side on my architectural line, I could absolutely put that in there. And I haven't had to model anything, no solid modeling whatsoever to see this work. Let's go back. Let me add my generator. There's my generator. Let's pull this down beside the truck. And that's not a lot of fun. Let's put the generator in the truck. Let's start taking advantage of these real-world objects and seeing if things fit together. And seeing if the scenario can work through where you can position the things as needed. If I go back over to my drawing, generators in the back of the truck, the generators on the parts list, and I can itemize it.
You can slice graphics also.
Sure. Yep. There's all kinds of ways to slice the graphics and do this. Another benefit, if I jump over, that's Navisworks playing with me. If I jump over into Navisworks, all of this data translates to Navisworks, every bit of it. So in the 2015 release of Factory Design Suite, if you make an asset that's a point cloud, you can bring that over into Navisworks. So there is that entire space. Let's zoom around back and see everything I've done. There's all of that data together. All of the machines are in place. Everything's ready to go.
Have you done file size comparison?
Yes, the point cloud assets are going to be bigger. Okay, absolutely. The asset does publish the cloud, so it is a larger file size. But performance is really what I care about. And for the most part, if I strip down the assets to their basic shape, these assets are not very big at all. So, to me, that's exciting. And remember what I said before. I may have discovered a process that will put me out of business. I might not be modeling anymore. I might just be working with point clouds from this point on. The whole thing will merge over. But this entire project, there's not a single solid model in here. And I was able to do a complete, think about it. I was able to take one scan from one facility, merge it with another scan from another facility, and see if it fits. And that's making better use of your scan data. Instead of just harvesting the exterior of a building, we can start using our scan to actually promote the use of point cloud assets or reality-enabled asset layout. All right, so I want to finish up. There are some pros and cons. I wrote these up here. Some of you've mentioned file size. Yes, these assets are larger in file size. Again, this reiterates what I mentioned before. In many cases, the component exists on your floor already. Why not take use of that? Make use of that to use that piece of equipment as your CAD data with the scanner. Scans can be faster. Solid models require many manual measurements. So you can bypass that. And anyone can make a point cloud scan. You don't have to have the experience of a 3D designer under your belt. As a giveaway, all right, for this class, for those of you who have Factory Design Suite, all the assets that you saw me use are available on the cloud. If you go into your Factory Design Suite and you type in point cloud, you can use every asset that you saw in this presentation today. So if you want to take this workflow back and you want to share it with your boss, get your Factory Design Suite. You can get it for a 30-day test drive if you want. And as long as you have enabled the cloud asset control so that your Factory Design Suite can see the cloud, you'll be able to download all those assets and use them. So take those, use them as you see fit. They're not all perfect, so keep that in mind if you're trying to show that functionality. To finish up, please, I know this is the first class in AU. If you like what you saw today, please take the time and go through and evaluate the class. Let Autodesk know what you think of the class and if this functionality would work for you. Let me know what you think. I'm sorry you couldn't see my iPad, but you saw the basics of what I was going to do. Also, I believe the session's being recorded, so eventually it'll be at AU Online. You can go up and look at the session there as well. Any questions as we finish up with what you saw? So when it comes to scanners, I don't. I primarily work with Leica scanners. That's just from my company point of view. But I know Ferro scanners are great. The scanner does depend on what you're scanning. So if you were to tell somebody you wanted to scan equipment, they might suggest a different scanner for you than if you're trying to scan a parking lot or a building or a massive space. So you do want to take that into account. Look for a versatile scanner, one that does both. Any other questions? Yep.
What's the benefit of using Vectorizing instead of raster design workflow?
Either way would work. If you use the raster design workflow, you could do it all inside of CAD. The Vectorizing tool is automatic. It's a couple of clicks and you're done. It simply automatically traces the thing for you instead of you having to go in and trace it manually. Yes? I have not, for Factory Design Suite, I have not bumped into a maximum footage area yet. And I have done 4 or 5 buildings in a row, so I have not run into a maximum square footage issue yet. So I'm not aware of one. All right. Any other questions? Well, listen, guys, I appreciate you guys being here today. I hope you guys enjoy the rest of your classes, and I hope to see, maybe some of you. I'm doing asset development tomorrow morning at 8 o'clock. So we'll get into the 3D modeling side of asset development tomorrow. So I hope to see you guys there. All right, you guys enjoy the rest of your stay.